Okay, I'm back. Right now it's drawing 140 milliamps at 120 volts. I have a 3.5 UF run cap. I have two microwave oven transformers. Just two. I tried three and it's too messed up. So, but two, the high voltage sides of each transformer are in parallel, and then I run the low voltage side in series. And I have in DC, about 16 volts coming out in DC after a full-wave bridge. And look, I'm charging this SuperCap. It goes slow, probably about 15-20 minutes. And I have a battery here I'm going to run parallel to this. The battery's at 12.24. So I'm going to wait until this gets to 12.24. Then I'll hook it in parallel. And then I will connect it into the infamous stat power inverter and run the motor with the stat power inverter. If I have that here. So I'm going to put this on pause and come back when this is up. It's up at 12 now. So hold on, I'll come back in a bit. Okay, I'm ready to plug in, pull it out of here and quickly plug it in here. And I'm going to review what I'm doing because maybe somebody wants to do the same thing, and also I like to go over my videos like days later or a week later and look at it all. So these are really good lap notes, you could say. Okay, 3.5 UF run cap. The high voltage sides of two microwave oven transformers are in parallel, and it's in parallel to the run cap, not in series. NOT in series, not parallel to the run cap. The low voltage side is in series to give that good voltage to charge a battery. And I had about 16 volts, and then I had 18 volts AC, and then after the full-wave bridge, it knocks it down to about 16 volts, a little bit less than 16. And if I crowbar which means I put an ammeter right across the output in DC, like just put an ammeter from here to here that's in DC, I had 1.5 amps flowing, which is pretty good. And so I shoved the DC of this output, about just under 16 volts, and I used that to charge up the SuperCap bank. It took about 20 minutes. And I didn't blow it up. I've been afraid of blowing that thing up, but just put in like a amps or 2 amps worth of juice. Don't just take your battery and hook it straight across. Fill this up first. So I got it up to 12.3, and the battery read 2.24, and so now I connected them in parallel. So this is like one gigantic battery with a SuperCap banks. These are 83 farad I saw someone on YouTube who tested them, and he said they're actually about 59 farad, 59 farad. And it can go to 16 volts, but after that, don't go over that. And it's slowly dropping, just being in parallel right here. Now, do I have this hooked up? I don't have this being charged right now. I took off the ground. I want to make sure I don't do something wrong here. So I'm going to go back to charging this supercap bank and this battery coming off this full wave bridge rectifier. There it goes. Nothing blew up. There we go. Now what happened over here? Remember it used to be at 0.05? That brought it up to 0.14, 140 milliamps input. This is the grid though. And it looks like it's slowly climbing. Yeah, it's going up a little bit. So I'm charging these right now. Now I have the green and the yellow wire. Yellow is positive, green is negative. I hooked that up to this. And the stat power is on. And now I'm going to plug that in here. Okay, I have to put it down for a sec. I'll come right back. Okay, it's now looped. The draw measuring from the AC output of this into the motor, it went down to 0.11 and it was at 0.14 from the grid. Don't know what that means, but that's what it is. And the battery is at 12.01 right now, so that knocked the voltage down across the supercap and the battery down to 12.01. I forgot to mention I have a 12.5 UF cap in parallel across the AC side of the full wave bridge. I do have that. It just dropped down to 12. And there's that. You know, I'm going to start putting things away. I don't want to leave this on overnight or anything, but here it is. I got the super cap in parallel with the battery. I suspect this is going to slowly drop. I'd like to see what... Yeah, there it goes. Maybe I can check the amperage going into the battery from the full wave bridge rectifier. Hold on 1 minute. Okay, I'm measuring the amperage from the full wave bridge into the positive of the battery and super cap in parallel. And it's 300 milliamps, 310 milliamps. And here's the voltage across these two. And it'll probably be another 5 minutes. I bet it'll be 11.97. I'm not sure. And we have this as the input from the AC input. from the inverter. I wonder if I take off this parallel cap, what sort of change this will be. This is parallel to the AC side of the full-wave bridge. Let's see what happens. Oh, that dropped how much goes into the battery. And it also has the same input. So that was no help at all. I wonder if there's a certain, that's a pretty big boost from 27, 26 to 30 when I plug it in. I'm going to try different size caps right here. I'm going to go with some other size caps, see if I can get more amps going into the battery and super cap. Wait 1 minute. Okay, I have to face reality here. We have 1.14 amps coming out of this battery going into the stat power inverter. This is in my previous videos. I said I wanted to keep this a mystery. But let's see what it is. It's an amps AC. And it says 1.16. Drawing from this battery. And what's going in, measuring from here to there, is 300 milliamps. So it's only about charging the battery about 30%. 30 what compared to what's coming out. So I need to shove more amps into this battery. Now the inverter's making a noise. I need to add one more transformer, also feeding power into there. And I'll be doing that hopefully tomorrow or the next day. So, okay, thanks for watching.